Hello viewers and my dear students. Welcome to session 1 on CNC profile milling video tutorial using EdgeCAM. This is in fact problem 1. Here I'll be showing you a demo on use of CAM software, that is EdgeCAM, for generation of G&M codes for a milling profile. Okay, these are all offline video help files prepared by me, that is Dr. B. Gurudat, former professor and head, Department of Mechanical Engineering, Bangalore Institute of Technology, KR Road, Bangalore 4. Presently working as Professor, Department of Mechanical Engineering, Nitya Meenakshi Institute of Technology, Yelahanka, Bangalore 64. Now here, as you see, the problem is this. This is milling. Okay, this is generation of G&M codes for milling, not turning. Okay, the profile they have given this way. A simple profile they have given this way. For this, as I told you earlier, you could write a manual part program also, just for the demonstration. That means it could be any complexity. For any complexity, if you undergo this procedure, G&M codes are generated. Maybe this problem may be simple, but the procedure gets extended for any complex problems. Okay, now this is the profile and all that. This is 100 mm, 100 mm square. Okay, and you have radius 25 arcs here. Okay, and the tool should move along the profile in this way. Okay, tool should move along. Profiling means the tool should move along the profile. And they have said use EdgeCAM to obtain a milling profile. That is this one on end mill cutter of diameter 4. You have to take a diameter 4 milling cutter, end mill cutter only, as shown. Centrally on a billet of size 120 by 120 into 20 workpiece. That means this is 100. The profile itself is 100. You have to have the billet size should be more than this 100. And they have asked you take 120 into 20, that is workpiece. Cut increment should be 2 mm and the total depth of cut should be 10 mm. That means every time it cuts, it should be 2 mm, 2 mm, 4 mm, 6 mm, 8 mm, 10 mm. In that way, it should cut like that. Okay, and I told you, assume feed rate of 50 mm per minute and speed of cutter to be 1500. You have to generate the toolpath, verify the toolpath, and perform 2D and 3D dynamics elimination, and analyze using tracking feature of the software, generate G&M codes, and all common things. Okay, these are all the common things what you find for every problem. Now you see here, the profile is this. Okay, the profile is this, and that means this is the profile, and that cutter of diameter 4 will move along the profile only. Will move. That is called profiling. The cutter of diameter 4 mm will move along the profile only. Every time the depth of cut will be 2 mm. That means first it will be 2 mm, then 4 mm, then 6 mm, then 8 mm, then 10 mm. Then finally this profile will have a total depth of cut of minus 10. That is 10 mm. Okay, that's what I given. Profiling 2 mm peck increment, total depth of cut of 10 mm. In that way, you should do this. Now see here, I have given the coordinates A, B, C, D. Okay, A is 0, 0, B 100, 0, C 100, 100, D 0, 100. This is 25, 25, 25, 25 and all that we'll do. Okay, this as you know here, we'll do it using EdgeCAM. Okay, now you see here, we'll shift over to EdgeCAM now. We'll shift over to EdgeCAM, you see here. Now you take down file, new here, okay. Then options, XY environment only you take because it is a milling. XY environment only you take. Okay. Then you go for polyline. Then coordinate input you take. Coordinate input you take. You see here, first is 0, 0, 0. Okay, this is first one. Then X is 100. Okay, it is a common origin, absolute units, all from the common origin. X is 100, Y is 0 only. Okay, you continue this. Okay, you got this X and 0, 0, this 100, 0. Then this point, no, X 100, Y 100. Okay, this point, X 100, Y 100, that also you take, that you continue. Okay, this point you got. Then you have to go this way. That point X is 0, Y is 100. Okay, carefully understand. X is 0, Y is 100. then you have to come back to the same point where we started. That is x 0, y also 0. Okay. Then once you do that, just say okay. Now once you do this 100 by 100 square you got, you have to get the radius and all that. We'll do that. Okay. Now you can say zoom extent. That is, you finish this. Okay. This you do. Okay. Once you do this, you have a provision here. Carefully follow. Here you have a provision here. Radius. Okay. Click on radius. Radius is 25. Okay. As you know here, radius is 25. Okay. In that way, radius 25 you take. You click on dynamic and trim, and radius 25 you say. Okay. Dynamic and trim option should be there. Okay, you say. Just you take this. You approximately take it here. This portion and this portion gets trimmed, and you get an arc. Okay. Then even here, if you take approximately to the center of this arc here, this portion and this portion gets trimmed, and you get this also. And even here also, if you take this mouse somewhere here, okay, as an approximate center, this portion and this portion gets trimmed, you get this. You click here also. Okay, even here also, this portion and this portion gets trimmed, and you click here also. In that way, you got, and then put the right button, you will come out of the polyline command. Okay. Now this R command and all that, you have come out. Now the profile, you have got it correctly. That is, this is 100, this arc is radius 25, this is 25, 25, everything you have done. Okay, as you know here, by clicking the, that is by rotating the center button, you can enlarge it or decrease it. Okay. Now once you have done this, you see carefully. Now you go for this project. Okay, go for this project. And you know very well the billet size is 20, no? 20 is the depth of, length and breadth is 120, 120. Okay, 120, 120. And the thickness is 20. I'll just do 20 here, minus 20. Okay, just say okay. And I'll click on this profile. Okay, then I'll put the right button. Now you see here, I'll go here, here, top view is the right now. If I go for isometric, automatically you can see this has a thickness of 20 mm. Okay. Now I'll go for the top view again. Okay. Now you see here, and the geometry you go, geometry, stock fixture you go. Stock fixture, automatic stock, box. Okay. Geometry, you take X minimum, Y minimum 10 only, because it is already 100. 10 mm this way, 10 mm this way, 10 mm this way, 10 mm this way means it becomes 120 mm billet. 120 into 120, and thickness is 20, I have already given. Okay, just say okay. Now you see here, this is the billet size. This is 120, this is 10 mm, this is 10 mm, this is 10 mm, this is 10 mm. In that way, this from here to here, it is already 100, 100, 110, 120. 100, 10 plus 10, 120. In that way, you have got this. Okay. Now, once you have done this, you see here, then if you go to isometric, you see clearly this is 120 by 120 billet. On that, this profile has to be created. Okay, carefully follow. This is 120 mm billet, 120 by 120 mm billet, and thickness is 20. On this profile has to be created, and the depth of cut for each thing is 2 mm. First it should be 2 mm, 4 mm, 6 mm, 8 mm, 10 mm. In that way, 5 times it has to the diameter, that is milling cutter has to move around this profile 5 times in order to have a total depth of cut of 10 mm. Okay. Now as you see here, this is 120 by 120 mm. Okay, and this is 20 mm. In that way, everything is going correct. And the cutter has to move along the profile and all that. Now, once you have come up to this, the design phase is over. Now, we'll go for the manufacturing phase. Options, manufacture you go. And compulsorily you take this Fanuc 3x.mcp. This only you take. Just say okay. Okay, Fanuk 3x.mcp you take, you do that. Then once you do this, see here, tooling you take, milling cutter you take, then as I've told you, the milling cutter diameter should be 4 mm. No, you diameter 4 mm you take, just say okay. This diameter, if they say 6 mm, you take 6 mm. Now the diameter they've said 4 mm, you take 4 mm. Just say okay. Now once you do this, then operations profiling you go. Very, very important. Here operations profiling you go. Okay, once you go for profiling, the profiling should be on this profile. Okay, you got 4 mm cutter now. This is 4 mm cutter. You double click on the profile. Okay, double click on the profile. Then right button you do. You have this. You don't change any values here. General climb for 0.01 tolerance. This offset and all that you don't give for this. Later on we'll give. Right now don't worry. Offset is 0 only. Then tooling. Feed rate given 50 mm. You take 50 mm. Plunge feed means, you see here, plunge feed means coming downwards. This feed is 10 mm per minute. 10 mm per minute. This is the feed 50 mm per minute. Okay. This is going along X and Y is 50 mm per minute. And this plunges feed in the Z direction. We feed in the Z direction is 10 mm per minute. And the diameter is 4. Corner radius, you see that it is 0. And depth, you see. Clearance is, you see here. This is after cutting. How much it should go? It is 5 mm above the workpiece. Okay, above the workpiece is 5. And you see here, importantly, this you see, depth is -10 and cut increment is 2. That means every time it should cut by 2 mm, cut by 2 mm, and the total depth of cut should be -10 mm. Okay, this you say okay. Okay, now initialization, everything we're done. You see here, the toolpath we have got. That means if you enlarge this, and say 1, 2, 3, 4, 5. This is 1 for 2 mm, -2, -4, -6, -8, -10. In that way, the toolpath has clearly been obtained. Okay, now what you do is, you see here, first we'll concentrate on 3D. Simulate machining you do. Simulate machining you do. Okay. Simulate machining you do. You speed control, you have it minimum for the time being. Now you just say simulate. See carefully. Beautifully it is going now. This is -2 mm. This is -2. Then now it is going -4. You can slightly increase the speed also by changing this. -4. Then -6, -8 and -10. In that way, you will have a slot created. That is going along this is called the profiling. And cutting the entire material, we call it as pocketing. What we'll do in the next sessions and all that. Okay, going along the profile is called profiling. See here, after this, it has come above by 5 mm. In that way, profiling has been done. Did you follow? This is the total depth of cut is -10 mm. It has gone 5 mm. Every time it goes here, it will be writing the toolpath. As you know, here, if I do this, you will get, again, you can do the simulation. If you do what exactly you've done, you'll get it. Okay, you can do this, and again, you can do the simulation and all that again. Okay, in that way, you can do the simulation and you increase the speed and all that. And in that way, again, you can have the simulation done in that way. Okay, now if you click on this, you'll get back to this. Now, in this, now we have come to the end of session 1 on this profile milling. In this session 2, I'll show you some of the other features and finer aspects of this. How exactly you have to understand and how to generate G&M codes and all that. We'll do it in the next session. Thank you very much for viewing. Thanks, friends. Thank you.